Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in previous video lecture we had studied operation amplifier, block diagram operation amplifier, then differential amplifier, etc. And in today's video lecture we are going to study the important parameters of operational amplifier. First of all, operation amplifier. It is basically high gain DC amplifier which is able to amplify both AC as well as DC signals faithfully. So it is op-amp, operational amplifier. The parameters of op-amp. The first parameter, it is input bias current. That is I suffix B, I for current and B for bias current. I suffix IB actually it is. I for current and IB, that is the input bias current, or sometimes it is given as IB. What is input bias current? It is defined as average value of current flowing through input terminals of op-amp when output is 0. That means it is a balanced amplifier. So in case of balanced amplifier, it is defined as the average current, average amount of current, average value of current flowing through input terminals of op-amp. So it is also states that it is half the sum of current entering or current moving through the input terminals of op-amp, current entering through input terminals of op-amp when output is 0, that is balanced amplifier. Now the circuit diagram of op-amp is going to display on your screen. From this diagram it is clear that it has two input terminals and two input potentials, input signals are there, that is V1 and V2, and because of these input signals the two currents, that is IB1 and IB2, are flows through input terminals, that is through inverting terminal and through non-inverting terminals. So IB1 is the current flowing through inverting terminals while IB2 is the current flowing through non-inverting terminals because of the input signals or input potential, that is V1 and V2 respectively. Output at this stage will be 0. So IB, that is input bias current, or it is a bias current, is equal to IB1 plus IB2 divided by 2. It is an average or half the sum of the input current when input is 0. So when output is 0, V output is equal to 0. Input bias current of op-amp is obviously very small, but it is a balanced amplifier. So obviously it is a very small and it is in range of nanoampere. It is very small. For IC741, IC741 is a part of our syllabus and it is operation amplifier. So in IC741, the input bias current is 500 nanoampere. It is 500 nanoampere. Now the second parameters, that is input offset current, that is I suffix IO, that is I for input, I for current, first capital I for current and suffix IO, that is input offset. So input offset current, the same diagram is there, that means V1 and V2 are the two input signals or input potentials applied to inverting and non-inverting terminals respectively. Obviously IB1 and IB2 are the current flowing through inverting and non-inverting terminals respectively. So in this case, the difference of input current, what is input offset current? It is a difference of input current flowing through inverting and non-inverting input terminal of balanced amplifier. So obviously output will be 0. So it is also defined as difference between two biasing current which gives a 0 output voltage. What is the statement? How will you define the input offset current? The input offset current is defined as a difference between the two biasing currents which gives a 0 output. So obviously I suffix IO is equal to IB1 minus IB2 ... obviously V output is equal to 0. I suffix IO, I that is current, I suffix 0, IO that is input offset is equal to IB1 minus IB2 when V output is 0. Friends, input offset current is also very low and it lies in range of 20 to 80 microampere. For general op amp it is 20 to 80 microampere, but in case of IC741 it is 200 nanoampere. It is 200 nanoampere. That is second parameter, input offset current. Now the third parameter of op amp, that is input offset voltage. So it is voltage, so V suffix input, that is I, and O. So V suffix IO, that is input offset voltage. What is input offset voltage? It is the voltage which must be applied between the input terminals, inverting and non-inverting. So it is a voltage which must be applied between the inverting terminal and non-inverting terminal to obtain zero output voltage. So obviously V1 and V2 which are applied to the input terminals, inverting and non-inverting, must be same magnitude. So V1 is equal to V2, it is inverting and non-inverting, output must be 0. But in practice, theoretically it is 0, but in actual practice we are getting a small output voltage, and to get that 0 we require 0 output voltage, and to get the 0 output voltage, the input offset voltage, that is V suffix IO, lies in range of 1 millivolt to 4 millivolt. That means the input offset voltage is also lies in very low range. It is between 1 millivolt to 4 millivolt. Theoretically V1 and V2 must be same, but practically there is a slight difference between V1 and V2, and that lies in range of 1 millivolt to 4 millivolt. In case of IC741, it is 15 microvolt. That is input offset voltage, V suffix IO. The next parameter, that is drift, DRIFT, drift. What is drift? Drift is a change in op amp parameter with respect to temperature. That means if the temperature of op amp varies, there will be the changes in parameters, and we have to find out the changes in parameter with respect to temperature. So drift is given as, it is defined as the change in op amp parameter with respect to change in temperature. So obviously there are two types of drifts. The first parameter, that is input offset voltage drift. Input offset voltage drift means it is the ratio of change in input offset voltage with respect to temperature. It is a ratio of change in input offset voltage with respect to change in input temperature, with respect to change in temperature. So drift, that is input offset voltage drift, V suffix IO drift. V voltage, IO, that is suffix IO, that is the input offset, and it is a drift. So V suffix IO drift is equal to delta VIO, that is a change in input offset voltage to the change in temperature, so it is delta T. So V suffix IO drift is equal to delta VIO upon T. That is input offset voltage drift. The second drift, that is input offset current drift. Input offset current drift. So it is defined as the ratio of change in input offset current to the change in temperature. So input offset current drift, that is I suffix IO drift, is equal to delta IO, that means change in input offset current, to delta T, that is change in temperature. Sorry. So input offset current drift is given by delta IO, I suffix IO drift is equal to delta IO upon delta T. The next parameter, the fifth parameter, that is output offset voltage. Output offset voltage, voltage that is V, and output, so OP, O suffix P, output offset voltage. So output offset voltage is the output voltage It is the voltage across the output terminals when the input terminals are grounded or when a common input is applied. That means when input terminals are short circuited and common source is connected to that terminals. Or mostly it is calculated or it is found out when the input terminals are grounded. So it is the output voltage when the input terminals are grounded. And friends, when the input terminals are grounded, input potential drops to zero level, 0 volts. So obviously output will be 0. But in actual practice, there is a very small output potential. And this output potential is known as output offset voltage. And obviously this output voltage is also in range of millivolt. It is also very low. That is output offset voltage. Now we are moving towards the next parameter, that is common mode gain, that is A suffix C. And friends, this common mode gain, it is already defined. We have already derived the common mode gain in last video lecture in differential mode. So common mode gain, what is gain? Gain is nothing but it is the ratio of output to the input. So A is equal to V output upon V input. So in this case, A suffix C, A that is gain, C that is common mode. So A suffix C is equal to V output upon V input. But friends, in this case, V input is equal to average voltage, that is V1 plus V2, that two potentials applied to inverting and non-inverting terminals. So it is V input is equal to V1 plus V2 divided by 2. By substituting this value, we get AC is equal to V output upon V1 plus V2 by 2. Rearranging this equation or by solving this equation, we get AC is equal to 2 V output, that is twice output voltage, to V1 plus V2. So that is our final equation. What is the gain of the amplifier? Sorry. What is the common mode gain of the amplifier? That is AC is equal to 2 V output upon V1 plus V2. Now the seventh parameter, that is differential mode gain, A suffix D, AD. Once again, it is a ratio of output voltage to the input voltage. So A suffix D is equal to V output upon V input. But friends, it is a differential mode. So in this case, V input is equal to V1 minus V2. But V1 is equal to minus V2, it is differential mode. That is also, we in last lecture, we also derived that formula. So by using this formula, we can easily derive that, or we can easily express that AD, A suffix D is equal to V output upon 2V1 or 2Vi. So the differential mode gain of the amplifier is given by A suffix D is equal to V output upon 2Vi or 2V1 or V2. That is our final equation of differential mode. So it is a differential mode gain. The next parameter, that is CMRR. Now what is CMRR? It is common mode rejection ratio. It is a common mode rejection ratio. What is common mode? Common mode, that means when V1 and V2 is equal to 0, or when V1 and V2 are of same values or of same magnitudes, then output must be 0. But friends, in actual practice, when the input signals are common, we are getting a small output signals, and this common mode signal may be rejected. Mostly we have to apply a differential input, and the amplifier must amplify the differential input. So common mode signal may be rejected, and because of common mode, there will be noise and there will be drift. So to remove this noise and drift, to find out the quality of amplifier, we have to find out the common mode rejection ratio. So it is a ratio how that amplifier rejects the common mode signals. So this ratio is given by, it is modulus of AD upon AC. AD, that is differential mode gain, and common mode gain. AC, that is common mode gain. So it is given by modulus of AD upon AC, and this equation is given by 20 log of AD upon AC. So by using this formula, that is 20 log of AD upon AC, we are going to find out the quality of our amplifier, means how that amplifier reject the common mode signal. That is find out by using this formula, that is 20 log of AD upon AC. And this common mode rejection ratio is measured in decibel. It is in range of 60 to 100 dB, or it is in range of 80 to 120 dB. Now we are going for the next parameter, that is open loop gain. Open loop means there is no loop, there is no feedback. We are applying V1 and V2, and mostly we are applying a differential input. So there is only one input, that is VD. It is given as VD. So in that figure, the input signal is defined as VD. It is given as VD. That is a differential. So what is open loop gain? The open loop gain is equal to, it is defined as the ratio of output voltage to the input voltage. It is what is gain? It is a ratio of output to the input. So in this case, it is also a ratio of output voltage to the input voltage. But what is input voltage? It is a differential input. So it is defined as the ratio of output voltage to differential input voltage when output is not feedback to input. There is no feedback. That means output is not connected to the input terminals. In this case, we are finding out the gain, and this gain is known as open loop gain. It is not connected, means the output is not connected. So it is open loop, and the gain of the amplifier in this mode is known as open loop gain. So it is given by A suffix OL. A, that is gain, OL, open loop. So A suffix OL is equal to V output upon V input, but V input is equal to VD, differential input. So gain of the amplifier A suffix OL is equal to V output upon VD, open loop gain. So obviously the next parameter is a closed loop gain. What is a closed loop gain? What is a closed loop? When the output is connected to the feedback, when the output is feedback to the input, that means output is connected to the input, there is a feedback. And in this mode, when there is a feedback resistor, in this mode, the gain of the amplifier is known as closed loop gain. That means when feedback network is connected between the output terminal and the inverting input terminal, mostly it is an inverting input terminal. When output is connected to the inverting input terminal, the sum voltage, the sum value of output voltage is fed back to input terminal. And gain of the amplifier in this mode is known as closed loop gain. So it is A suffix CL. The circuit diagram of that op-amp in a closed loop is displayed on your screen. From this diagram, it is clear that the input voltage V input is connected to the inverting terminals through input resistor Ri, while the output voltage is fed back to inverting terminals through feedback resistor Rf, and non-inverting terminal is grounded. So in this circuit, the output voltage V output and is a V input. So ratio of that output voltage and the input voltage is a gain, and that is known as closed loop gain. So friends, A suffix CL is equal to V output upon V input. But friend, in this equation there is negative sign. This negative sign implies that it indicates that the output is out of phase with the input. Why it is out of phase with the input? Because it is connected to the inverting terminals, and output is always 180 degree out of phase with the input connected to the inverting terminals. That means if the input is positive, output will be negative, and if input is negative, output will be positive. So in this case, the minus sign indicates the output is 180 degree out of phase with the input. So the closed loop gain is equal to minus V output upon V input. This closed loop gain is also calculated by using formula Rf upon Ri. It is the ratio of feedback resistor upon the input resistor. That formula is also used to find out the gain of the amplifier when the feedback is connected. That is a closed loop gain. Now we are moving toward the next parameter, the parameter number 11. That is slew rate. Slew, slow. What is slew rate? When input of op-amp get changed, When when input signal get changed, obviously there will be change in output. But friend, the change will not occur instantly. There will be some time delay. It requires some time to change its output signal. And that is given by using slew rate. So what is slew rate? When input of op-amp get changed, the output also get changed. But change in output does not occur instantly. It requires some time. Slew rate is defined as rate of change of output with respect to time. Means how much time it requires to change the output parameters, to change the output signal. That is slew rate. So slew rate is defined as the rate of change of output with respect to time. It is also defined as maximum rate of change of output. Maximum rate of change of output when the supplying the rated input. That means when the input changes, there will be change in output, but requires some time, and we have to find out that ratio that gives a slew rate. And slew rate is given by delta V output, change in output. So delta V output upon delta T, in this case T, that is time. And slew rate of our IC, that is IC741 op-amp, is 0.5 volt per microsecond. Change in output, that is 0.5 volt. Change in time required to change the output, that is microsecond. So 0.5 volt per microsecond, that is the slew rate of IC741. Now parameter number 12, that is input impedance, that is ZI or ZIP. ZI, that is input impedance. What is impedance? Impedance, that is resistance. So how the resistance is calculated? So obviously by using Ohm's law. So input impedance is given by, it is the ratio of input voltage to the input current. The input voltage applied to that input terminus and the current flowing to the input terminus. The ratio of that input voltage and input current gives the input impedance. So ZIP, Z, that is the impedance, IP input. So ZIP is equal to VIP upon IIP. That is input impedance. And input impedance of op-amp is very high. It is in the range of mega ohm. That is input impedance. Next parameter, obviously output impedance. So it is the ratio of output voltage to the output current. Very simple. By using Ohm's law, we are find out the output impedance, that is output voltage, ratio of output voltage to the output current. So Z output, Z suffix OPZ output is equal to V output upon I output. And friends, output impedance of op-amp is very low. Next parameter, that is power supply rejection ratio, PSRR. Similar to CMRR, it is PSRR, power supply rejection ratio. What is power supply rejection ratio? It is the ratio of change in input offset voltage. Change in input offset voltage to the change in power supply voltage. Power supply mostly plus minus 12 volt. The range of power supply is plus minus 10 volt to plus minus 18 volt. If that power supply voltage get fluctuate, we have to find out the ratio of input offset voltage to the power supply voltage is known as PSRR. It is the ratio of change in input offset voltage to the change in power supply voltage. And for IC741, that is op-amp, for IC741, this PSRR is 150 microvolt, because input offset voltage is very low. It is in the range of microvolt or it is in the range of millivolt. And in this case, it is 150 microvolt. So it is 150 microvolt per volt. Change in input offset voltage to the change in power supply. Power supply voltage lies between 10 volt plus minus 10 volt to plus minus 18 volt. So it is given as 150 microvolt per volt, that is for IC741. So friends, these are the parameters of operation amplifier. In next video lecture, we are going to study two more parameters, and that is frequency response of op-amp and frequency response of op-amp, and we are going to study the one more parameter. So friends, keep watching these video lectures. In next video lecture, we are going to study the another two parameters, that is virtual ground and frequency response. So friends, keep watching our video lectures. Bye, take care, see you again in next lecture, in which we are going to find out the two parameters, the two important parameters, that is virtual ground and the frequency response of op-amp. So friends, bye, take care, see you again.